welcome back to the another session of this 5 days faculty development program. The topic for the session is QGIS on GIS, basic GIS in operation and analysis, presented by Dr. Prasun Gupta, scientist at Geoinformatics Department of Indian Institute of Remote Sensing, Dehradun. He has completed his bachelor's in the year 2006 from KSIT Bangalore. Later on in the year 2008, he joined ISRO after having a brief career in Tech Mahindra. Programming and application development, open source GIS and modeling, and quantum computing are his area of expertise. Sir, we are really thankful for you to joining us for this session and request you to start the session.
Okay, thank you, madam. Good morning, everybody. My name is Prasun Gupta. I am with IIRS Dehradun. And today we will see the demonstration of a software called QGIS, which was earlier called Quantum GIS. Sorry. Okay, so before I start, let's see some. Before I start the actual demonstration, let's see some basic information on what is QGIS and why we need it, what are the alternatives, and why is this important. So before I start, can anybody just, I think you can put in your chat whether you've used GIS or whether you know something about GIS. Is there a chat window? There's no chat window. Okay. Team members. Okay. Okay. Okay, so there is no way to. So it is a one-way interaction. Fine. So QGIS is a user-friendly open source GIS software. It's called a GIS client because you use it on your system normally. Let's say your laptop or your desktop, or and it can be used to visualize, manage, edit, analyze data, and make printable maps. It includes, so it itself is pretty powerful, but recently it has been integrated with other open source softwares like GRASS and Saga and R, the R software that you use for statistics. So it becomes more powerful. Even recently it was, I have seen some tweets on integration with PC raster and so on, and TauDem and Ilvis also. So some of their functionalities are also built in inside QGIS. So it's a very powerful GIS software. It runs on all operating systems. So you can run it on Linux machines or Unix machines, MacBooks, and even your Windows system, which is most commonly available. It supports numerous vector, raster, and database formats. So there are hundreds of rasters and vector formats, and QGIS allows you to add and manipulate and make maps using all of these different formats. So this image on the left hand side is what the what QGIS looks like. You can add your layers in the layer panel. Your images will appear here in the map display. And then there is processing toolbox where all the analysis can be done. My voice is audible, yes?
Yes, sir.
Thank you.
Yes, sir.
So, I will emphasize on this thing of it being open source. And so is open source a new thing? Actually, no. We've been using open source since a very long time. And it is more popular than other softwares that you may have paid for. So, for example, if you're on the Windows operating system, there are 2-3 things which come along with the Windows operating system that you have paid for. One is their media player, one is their browser, Internet Explorer, and so on. But you normally don't use it. You install Chrome or Firefox and things like that to browse your internet. So why not Internet Explorer? Because it's not very friendly. It doesn't open all the pages, has a very clumsy interface. So you download and install Firefox or you install Chrome and you work on it. But you don't pay for it. So where did the software come from? Who made it? Where is he getting money from? So these are all open source softwares, normally volunteer driven efforts. People from across the globe, they initially started like a project and then build on top of it, and more people join, and then it becomes a popular product. So Firefox is a very good example when we talk about internet browsing. Similarly, for playing your videos and movies and all that, you won't prefer Windows Media Player. It will not play half of your files. Doesn't have those keyboard shortcuts and all that. So you prefer VLC. You download VLC and you start using it. You don't worry about having to pay for it or who made it and all that. So VLC is also an example of open source software. Similarly, other domains, if you are in academia, you're probably using a learning management system which is based on Moodle. If you're into statistics, you're probably using the R language. And all of you are doing probably some internet transactions. And these are based on the SSL security layer, which is also an open framework. The Linux operating system, the Apache web server, all the websites are hosted using Apache. And then you have these web programming language like PHP, then other languages like Python, databases like MySQL. These are all different examples of open source tools which you are probably using and not knowing that this is an open source thing. So open source doesn't mean that it is like you don't have to pay for it. That is one of the qualities of open source, that you don't have to pay anything for it. But that is not what it was meant for. Here, the free software or open source software doesn't mean that is as in it is free lunch or free food. It doesn't refer to the price, but as in free speech or freedom to run the program for any purpose. A lot of times these foreign countries, they will impose some embargoes. No, we cannot give you this software because of this reason. You cannot run this software for this purpose. You can only run it for this purpose. So open source softwares do not impose such restrictions. You are free to run on any machine for whatever purpose. You don't have to tell what purpose you want to run it and all that. You have the access to the source code. That means you have the actual program in which the software is written. For example, the software that I am using right now, PowerPoint. PowerPoint is a software. So software is made using a programming language, something like C++ or Java, or Python. But they don't tell you the programming, they don't give you the program. Of course, you'll say, well, I don't need it. But if you have access to that source or the program, you can study how it works and probably change it to make it better. Okay. So for example, you are using VLC media player or you're using QGIS and you say it has too many functions. I don't need all this. I can strip it down, make it a smaller file and it works for me. So you have access to the source code, you can remove portions, you can add your own portions and you can make the program better in one way or other. So that is what the open source softwares allow you. All these paid softwares, proprietary software or closed source software as it is called, they do not give you this freedom. They don't show you the source code. It is all hidden. It is proprietary. And in that way, you don't know how it is working. Maybe it is stealing some data, but you will not never know from your by using the software because you don't have access to the code. The third one is redistribute copies. I should have written legally redistribute copies. A lot of you probably know of places where you can go and buy illegal pirated copies for as low as 100 rupees. You go there, you say, I want ArcGIS, 100 rupees, they will give you a CD. But in your college or your somewhere, they are paying lakhs of rupees for a single license. So it is, in India, it is okay, but in abroad, it is not. So all these problems do not arise with open source. You are free to redistribute copies of the software legally without having to worry about legal aspects and breaking the law. And the final is redistribute copies of modified versions of the software. You have invested some time, money, effort, energy to make the software better. Okay, some way. Then free softwares allow you the freedom to redistribute copies of the modified versions. Whatever new version you have created, you are free to redistribute those copies. So these are all what open source software, these are all the power which the open source software gives you. And as I told you, free open source softwares are there in all different types of domains. Playing your movies, writing your document, hosting a website, and also in the field of GIS and remote sensing. And there are several different tools, not a single tool. So if we talk about the most commonly used, which is the desktop tool, you will need some software to on your system to work on the geospatial data, or spatial data. So in that domain, there are several softwares. For example, QGIS, JUMP, ILWIS. So if you've been working with GIS, you probably know about ILWIS because ILWIS was one of the initially most popular softwares. And initially it was closed source, but sometime during the 2000, they open sourced it. Now it is available free of cost. And Newdig, Saga. And then for expert users, for those who are comfortable with command line, writing some commands and all, Grass GIS and also. Grass GIS has a very interesting history. Grass GIS is one of the first GIS softwares ever made. In 1984, the US Army open sourced the source code for the first Grass GIS version. So that means before that, they were already using it. and then they open sourced it in 1984. And since then, it has gone several developments, and now, since it is the oldest, it is also the most powerful because a lot of effort has been gone into people using it and making it better and all that. So GraphGIS is a very powerful software, but it is, I would say, it's used for expert users because many a times you need to write some commands to work on it. Uh, but yeah, but QGIS is one of the softwares which any beginner or any intermediate user can use and do their work. Then there are databases. Once your data becomes large, you have multiple data sets, then you must use a spatial database or a database management system like MySQL and PostGIS. And they both have spatial extensions. That means these are normal databases. PostgreSQL is a normal database where you can store tabular data, but its extension is called PostGIS, which allows you to store spatial data in databases. Then you have code libraries. If you know programming, any language, C, C++, Java, Python, Perl, PHP, anything. There are these different libraries which can be used to read and write raster and vector data or do your spatial analysis. So if you know programming and you want to build your own tools, then there are existing libraries which can help you do your mundane tasks like reading, writing data or doing the analysis. Then if you want to create some maps which can be displayed on the web, for example, you want to create something like Google Maps or Oven Maps, where you want the map to be displayed on your browser, then you will need to know these softwares like GeoServer, OpenLayers, Leaflet, GeoEXT. So these are very powerful softwares. You would be happy to know that Bowen, that is ISRO's GeoPortal, is entirely made on open source stack. That means they're using all these different technologies, some databases, some web mapping, some web services. These are all open source, and they are using it to make this the platform. Then you have different data visualization softwares. You can create your visualizations and maps in QGIS also, but you have special type of data like climate data or some time series data, and you can use this GRADS and Geoda to visualize the data. Again, if you have large amounts of data, you would require something like a catalog to browse through the data. GeoNetwork is such one software. It is the world's most popular spatial cataloging software. And frankly, there are no popular commercial equivalents of it. So this is the most popular software in both open and closed source because everybody is using this. Then I also want to highlight something called data collection softwares. Many a times you have to go to field as a remote sensing or GIS person or a geoscientist. You will have to go on the field to collect data and then validate with what you see in the satellite image or see what are the patterns of data on the ground and things like that. Then how do you collect data on the field? You go in the field, you take your notepad along with you, and then you write your readings. I think, yeah. So there are several softwares which help you collect this data on the field. One is called Open Data Kit or ODK. The geospatial equivalent is called GeoODK. And then IIRS has made its own software called Q Real Time. This is also some software which is used for field data collection. So what happens? You normally an officer will list out what types of survey questions. For example, what fields will you collect? How many houses? How many people live in? What kind of damage? Or what is the phenomena happening? Or let's say what type of tree? Things like that. You will want to take a picture. You want to take a GPS location or something else, or maybe take a video or things like that. You want to collect all this data from the field. But you go there, you write down all the information in the paper, and then you come back to your lab and you type that information in Excel or someplace. Some information gets lost, some coffee gets spilled on the data. So there is human error. What you recorded in the field, you cannot read it. Handwriting cannot be read. Somebody recorded, somebody is reading. Human interpretation is different. So all these kind of problems will arise. So instead of doing paper-based data collection, uh, there is a free and open source equivalent called ODK, which allows you to convert the questionnaire into a mobile app using a simple Excel type of tool. You just open their XForm designer. It looks very much like Excel. You type your questions and you type what type of answer you want. Whether you want a text answer, whether you want numbers, or whether there will be some radio buttons, like some options to choose from, a geolocation, an image, and so on. So you collect, you enter that information in your XForm designer, and then that data can be uploaded to this tool called Aggregate. This then converts it into a form. It's like a mobile app in your Android phones. It's called the ODK Collect app. You can install it from the App Store. And this form that you created on your desktop will get transferred here. You take that app to the field, you collect your data. If there is network connectivity, sometimes you have to go in deep in the forest or in the mountains where there is no network connection. So all the data that you collect will stay in the mobile app. As soon as you get network, it will get transferred to the server. And somebody who's sitting at the server or has access to the server can visualize all that data coming in real time. So here I am showing you one row is one point, data point which is collected. There is an image, there is an lat long, then there is some information like building information, structure type, number of stories, number of the what thing was used to make that structure: wood, steel, concrete, and so on. So we had done some. So this is an example uh, uh, from a survey done to estimate damage due to an earthquake or damage due to a flood, and so on. So it's just like a mobile app. You will get the screen, you can swipe, and you will get the next question, and you can answer the questions, take the image, take the lat long. All this is available, and you can, on the server, you can make a map out of it, where all the data point is being collected, create different types of visualizations like bar chart, pie chart on all this numerical data and so on. So these are different apps to use to do this kind of work. And this kind of data collection has become very popular. The government of India is using it extensively to do data collection from the field. For example, in the Manrega program or in the IDWMP program, to assess how much construction has been done, to assess whether funds has to be released, and so on. So here I am showing you a success story of a project called Manu. Manu stands for Map the Neighborhood in Uttarakhand. This was done for damage assessment post the Kedarnath floods, which happened in 2013 here in Uttarakhand, and large areas were damaged. there was extensive damage to buildings, roads, bridges, because these are all mountainous regions, and there are bridges connecting different parts of the valley.
मला पेनड्राईव्ह ना कोल्हेसांच्या पीसीला आहे. तुम्ही जाऊ शकता. समोर माईक इज ऑन. आतून नाही, बाहेर ना, प्रिंटरच्या बाजूला आहे. असू दे, फक्त ना लक्षात ठेवा, मी विसरतो ना. मध्ये कोण तिसरा माणूस गेला की म्हणजे मला धडकी भरेल इकडे, बाकी काय नाही. काय बोललेलास का? हा माहिती, पीपीटीचं तेच असतं कदाचित. पीपीटीचं. हॅलो हॅलो.
Yes, madam.
तेवढ्या जोरात काय यांचं बटन दाबतोस.
Do the organizers have failed to mute everybody?
Just we are checking it down.
हॅलो.
Yes, ma'am. Yes, ma'am. I think it's working now.
Okay, thank you. So I was talking about this project which was done post the Kedarnath floods in 2013, and with the help of 4 universities, students, we were able to collect over 10,000 different points of all the damage which were happened, and all that data comes to Goan, and here all these blue pegs that you are seeing are basically points that were collected. If you click on any point, you will see a photo of the damage, what type of damage, it's a landslide, and who took this photograph or data point, and when it was taken, the mobile number and everything. So using this kind of data, we collected about 1,000 points of damage to buildings, roughly 500 points for damage to roads, and 50 points for damage to bridges. And using this information, we did some analysis based on which were the most impacted regions, and so on. So this is a very interesting use case of field of ODK-based data collection. Remember, the entire software chain, right from collecting the data to visualizing it on the web, it is all open source. So now we'll go to the actual demonstration. That is, I'll show you how to make a beautiful map, something like this, of your own college or your own district. It's a very simple map. It has a satellite image of the district of Bilaspur in Chhattisgarh. And this is where the college is located, an image of the college, and other map elements like grid, north arrow, scale. You could add a legend and all that. Very simple map, but just to give you a feel of how you can do all this in GIS. Using everything is free. There is except the computer and the internet we are paying for. Everything else is free. There is no price you have to pay for the software, no price for the data, and so on. So, of course, QGIS is a very popular GIS software, and you could learn many things. So, as part of the IIRS outreach program, we have made certain videos. The links to the videos, it is a 3-part series. A link to the videos and the data used is there in this link here. You can just note it down, bit.ly/, QGIS-IIRS. So this is the link where you will get information of 3 of my videos and the data which have been used to create those videos. And so that is one place where you can start learning. The other is this website called qgistutorials.com. This was made by a gentleman by the name Ujawal Gandhi. He was earlier in Google. He is an alumni of IIRS. And these are very extensive, very good. Again, it has the data also, so you can use it to learn this GIS software. Most of you, as I understand, are from academia. So you probably have heard of this project called Spoken Tutorial from IIT Bombay. They have also made their videos on QGIS, so you can go there also to learn. Finally, if you are really interested, you should refer to the official documentation. That is QGIS docs. If you just search, you will get the documentation for the QGIS software, and that is where you can learn from. So now I'll close the presentation and we'll go to the demo, and we will see how we can work in QGIS. I had shared one file with Madam earlier on how you can install QGIS. It is not very technical. All you have to do is open Google, type QGIS, and go to this first link. Welcome to the QGIS project. If you scroll down, there is a download now button. Just click here and you download the latest version. It is 3.16. So if you have a 64-bit computer or a 32-bit computer, based on that, you can download this file. It is roughly about 300 to 400 MB. Simply download and double-click and install. No need for any license or key or hardware key. Nothing is required. Just simply download and you have to click on next, and that's it. You will get it installed. Once you install it, you will, in your start menu, you will see this option like QGIS. It will come pre-installed with different other softwares like GRASS and Saga, but we are primarily interested in this software called QGIS Desktop. Once it is installed, if you just click on this QGIS Desktop, the software will start. And you don't have to do anything like adding a serial key or nothing. It's a free software. Just download and install and it works. Once you start running it, you should see an interface which looks like this. You may slightly see different. So if you have made some projects, it will come in this center pane here, recent projects. Some news about what are the current updates about QGIS and all that. This is called, the left hand side is called the layers panel. This is where all your layers will get listed. On the top left, this is called the browser panel. Here you can go to your different drives like C drive, D drive, and you can add your data directly from there also. The best part about this software is you don't have to go anywhere. You can just simply drag and drop the data. Let's say I have this DEM, a digital elevation model for Dehradun. I can just drag and drop this here and it should open. Okay. So do you know what is a DEM? A lot of you are civil engineers, so
Digital elevation.
So digital elevation model.
very good. And would you know where you can get it for free?
So that I don't know.
Sir, maybe downloaded by USGS and Google Earth.
Very good. So
Sir, we can also download from natural earth data, sir.
DEM. Natural earth data में DEM भी है. Okay, let's see. They have kept some rasters, I remember. It was DEM, I did not know.
Here we can download Aster Dam data.
Okay. There is some raster mentioned, so they have some shaded relief. Okay. ठीक है, but all this is
Sir,
fine.
not natural, sir. Earth data. Earth data is there, sir. Earth data.
Okay, no problem. Let me tell you a new source. There are different sources. Thank you for telling all this. There is one very popular called SRTM. This is available from USGS. There is one called Amsterdam. There is one called GTopo. This is also very popular. These are normally all of Aster is from JAXA, if I remember correctly. GTopo is from USGS. SRTM is also from USGS. They are all varying from 30 meter, 90 meter, 1 kilometer, and so on. But did you know that there is an Indian data also called Cartosat satellite, an Indian satellite series called Cartosat satellite, and the DEM made from this Cartosat satellite is called CartoDem, and this is also available for free. It is also at 30 meters. Okay, so where you can get it, you have to go to this website called Bhuvan. So open Google and you type Bhuvan ISRO or something. Bhuvan ISRO will require. Once you type Bhuvan ISRO, you will get this website called Welcome to Bhuvan ISRO's Geo Portal. Once you click on it, you will go get this website. Here, the first link, which is Bhuvan 2D, is something like a Google map. You can see the entire map of India, and you can zoom into different areas, and you can see similar to what Google Map shows you. Okay, so let me go to Bilaspur only. And if you see, this is what is the name of this river?
Arpa River.
Okay, good. So there's a river on which this city is located. You can click on satellite and you get satellite image. And you can click on terrain and you can see the DEM and all that. Okay. So just like Google Maps and much more, you can see different other information like water bodies and other layers like thematic layers, governance layers, 3D and so on. It's very powerful. You can explore this, but this is not the topic of this lecture. There are a lot of videos on the internet also on how to use this platform. What I'm interested in is in this one, Open Data Archive. It says free download. To click on this, it will take you to this portal which is called Noida. They initially called it Noida. I think they call it Open Data Archive now. NRSC Open Data Archive. And here you can download, if you go to this option which says Cartosat 1, you can download the CartoDem. Okay. So if you select CartoDem, it will show you India in different tiles. You can select the tile of your interest. So let me say I want to download for area around Bilaspur. So if I search for Bilaspur, it shows me This is where it is. So let me take this tile. So let me no. So I click on tiles and then I go to start, then click the tile of interest, stop, next, and you will see that it will also show you a preview of that DEM of that area. So you can see a small image it is showing for the DEM of that area. You can just click on download here and download it. But before that, I think I'll have to log in. So it's a very simple login procedure, just like your email. Since I have time, I will show you how to do it. Just a second. So what I'm doing is I'm trying to download the DEM for any area. For example, it can be your area if you're anywhere in India, from north to south, from east to west, anywhere. Just search for the name of your area and you should be able to download. Let me show you how it works. So I say I want if you know the map sheet number, the Survey of India map sheet number of your area, you can simply type that map sheet number here, or you can search for the name of your place and you can select that tile and you can download from here. It is asking me to log in. I will just log in. So it's not a very big file, it is a small file. And it's about 9.29 MBs. Similarly, if you want some satellite data, so some satellite data is also available for free. So you see list 3 is written here. So list 3 data. Again, let me search for Bilaspur. Now you see the grid sizes have become smaller. Just let me take one tile. You will see that for this tile, multiple date images are available from October 2008 up to February 2018. Multiple images are available. So let us take, over 10 years of images are available for free. If you click on view, it will show you a small preview of this. So let me download this one only, looks nice. And oops, I'm downloading the same file again. Sorry. Yeah. So L3 stands for list 3. List 3 satellite data for 2018 image. So this is also about what, 5 MB or something, 5 MB, and this DEM was 10 MBs. So now I have two files, DEM and the satellite image. I will just copy it. I will put it in a folder somewhere. Okay, let's create today's folder. Let's call it QGIS demo. Let's paste it here. And let us unzip it. Okay, so this CDN is the DEM, L3 is the list3 file. So we go to CDN. Let me remove this from GIS. And let me simply add the stiff file. And there you go. So this is the DEM of region around Bilaspur city. And so you saw that the software is free. The data I have downloaded in front of you from the Bhuvan website, which is also free. Using GIS, you can do several things, like first create a pseudo color. This is normally how I think DEM is shown, with blue showing the lower elevations and red showing the higher elevations. And so you can zoom in, zoom out with the scroll. There are multiple options. So there is a magnifying glass here and here, which help you drag and zoom into a specific area. You can see the streams or the geomorphology, or you can click on this button to zoom out. There is an identity tool, I, which if you click on any pixel, it will tell you the lat log of that pixel and the height in meters. Okay, so if you know the lat log of your area, you can simply type it here in this coordinate box at the bottom of the screen, or you can simply click on that area and you will get the height in meters. So the lowest elevation is roughly about 171 meters, and the highest elevation is roughly 980 and so meters. In fact, there is something called the histogram here. You can see the range of elevations in this tile starts from anywhere as low as 165 meters and goes as high as 900 or so meters. So this is a very powerful software. You can visualize the data in whichever way you want. You want to create a different kind of palette to view the data. You can specify the color ramps, can specify these intervals. Normally, showing these many is not nice, so we'll create 5 intervals at good numbers like 150, 300, 500, and so on. So you can create these intervals, these bins, they are called 700, and so on. Let's say 900. Okay. So I have 150, 300, 500, 700, 900, like these bins are created. But so what do these colors mean? So if I'm zooming in very much, you will see that there is a gradient from this orange color to this purple color. That means this 500 means that 500 means that all the elevation ranges between 300 to 500 are shown in this gradient of colors. But some people want, no, I want exactly what is the, there should be discrete regions within these classes. So that is a different interpolation option. If you select discrete, now you can see, to make out more clearly, that all the southern part is less than 300 meters. This blue areas, this central north part is between 300 to 450 meters. On the west, on the east, north, we see 450 to 600 meters. and the highest peaks above 750 meters and so on. So these are just showing the DEM. But the, sorry. Yeah, but the best part would be to visualize this in 3 dimensions. So let me go back to the first one, the DEM. And using certain plugins, we can visualize this data in, sorry. So this data is currently in a geographic coordinate system. We will convert it to a projected coordinate system, and then we will use a plugin to create the 3-dimension view of the same. So now you can see a very nice 3-dimensional view of this area, and all this is done in QGIS with the DEM, which is downloaded from NRSC. And here you can see all the hills around this Bilaspur city, and I think there was some lake or a dam here, water body here, and some river channels, and so on. So this kind of beautiful 3D visualization can be made very easily. Just have to add the data, change the colors, and run a plugin. So this is just a tip of the iceberg, something very nice to view. This is what I started with because it appears very nice. But eventually what you would want is a map, something like this, which can be printed or which can be published and so on. So we'll see that also. Yeah. So before I go there, I also want to give you a feel of how satellite data looks here. Now the satellite data that we downloaded from list 3 satellite, you are seeing the 3, they are as 4 black files. These are different bands. Somebody, I think Hina ma'am told you about remote sensing and spectral signature and different bands. So I'll just add one file. This is band 2, that is the green band of Bilaspur city. Here you can see the channel, and here you can see, sorry, the city and all that. So this is the reflectance in the green band. Then I have the red band and the NIR band. So using these 3 images, I can merge them, or what is known as stack them, to create a false color composite. Madam must have told something about a false color composite where the vegetation appears as red color. So let me just stack them. Let me add the 3 files first here. So I have band 2, 3, and 4. And using simple operation like merge, I can stack these 3 bands. So I will take band 2, 3, and 4, and I will say stack them, create a, what was the input data type? Sorry. The input data type is unsigned int 16. The output can also be the same. So we will take the 3 bands, unsigned 16. That's it. Let's create a temporary file, and it has created this merged image. Let me remove the existing. Oh, sorry. I think I made a mistake. I'll just redo it. merge the three bands and place them in. I have to check this option, place each input file in a separate band. This I didn't do last time, hence that issue. On slide 16, there I go. Now I can see some colors here. These colors are coming from the three bands. They are now merged into this RGB composite, but they are not, the vegetation is not appearing in red. That is because you have to change the band combination. So the last band, that is band 3, will go to red, band 2 will be green, and band 1 will be the blue band. And now you can see a more familiar looking false color composite. Here you see this dense vegetation around this channel. So I think some forest or something has come up, but the dense vegetation is here. And then you see these rectangular uh, 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 plots. These are farms. These are agricultural farms with standing crop, green crop. So they are appearing in red and pink color. These are either harvested or having stagnant water or something. Some, I don't know what crop it is, but yeah, this information is used for interpreting what feature are there. There is some quarry here, some kind of ore extraction is happening here. This is a river channel. All these bridges are very visible. There are bridges across on this channel, many of them, and so on. So it's very nice information is available. But how could I? Is it possible to merge this satellite image with this DEM? Can I see this information in 3 dimensions? Yes, you can. Again, open that same thing, and now, but this area is not very, there's not much change in elevation. I don't know. Yeah, this area is very flattish, so I cannot make out the difference. But the same thing for Dehradun, let me show you for that. So I showed you how to download the images and the DEM for, yeah, as you can see in DEM, it is a very flattish area. But let me add, I think I have the same data for Dehradun. Now Dehradun is at the
We can't see the screen changing. It's still the three bands, which you did.
okay. So we'll just wait for that screen to refresh and let me know if you see something new on your screen. So if somebody seeing the false color for Dehradun, some other different area on the screens.
I think so.
No,
Your screen is freeze, sir.
it is Bilaspur image where we merge the three bands.
Okay. 1 minute. Then the best thing to do would be to reconnect. Then should I reconnect again so that
Yes, sir.
screen...
Share it again. Share it again.
Yeah. But okay, I can stop and now can you see something?
Yes, sir. Yes, sir. Map is visible.
Very nice. Fantastic. This is the false color composite for Dehradun area. This is the Dehradun city in the center, which is coming in the blue cyan color. On the south, you can see these pink colors. These are all farms.
Sir, nothing is visible on the screen, sir.
Okay, fantastic. So I will disconnect and reconnect again. Okay, so the organizer will have to make me presenter after I reconnect.
Sir, do one thing, you try it again, sir.
Yeah, I'm doing that.
I think I was able to see that screen. So, is there someone else to which the screen was not visible?
Ma'am, it's me. I was this screen was not visible to me, sir. Ma'am.
That
DP,
was not visible to you.
the screen was visible.
I think, ma'am, huh, that's the thing I'm trying to mention, that it could be possible that your net connection would be lagging and that's why you are not able to watch the screen, but I was able to watch the screen. So you need not to disconnect. You may continue, sir.
Now it is visible, ma'am.
Yes, yes, it could happen, sir. It happens with everyone. All of us are facing this issue. So
Okay.
you may continue, sir.
Right.
Prasun, sir? Yes, sir. Thank you, sir.
So what I'm trying to show here is the satellite image, the LIS3 image false color composite for Dehradun area. All the cyan color that you see is settlements. All the pink colors that you see on the south are farms. And this red, deep red color is the reserve forest or forest ranges. These are there on the south and the north of the city. And so you can clearly make out the type of land cover. This is forest, then urban, and so on. And this typical feature that you see here in the center, this is the Forest Research Institute. It has this typical long walkway, and then they have the main building, and then they have these forest farms of their own. And right adjoining is IMA and so on. So this software allows you to do various things. The very basic is measure. So let us measure how much you will have to walk if you get down on the road and if you want to walk right up to the main building. So it is roughly in kilometers, it is roughly about 1.2 kilometers, right from the main road, that is Chakrata Road, to the main building is roughly about 1.2 kilometers. So similarly, you can make measurements for anything. Let's say you want to measure what is the width of the city or the breadth of the city. So roughly about 21 kilometers east and west, and roughly about 15 kilometers north and south. So very small city and surrounded by hills on the north, two rivers on the east and west, and again forest range in the south. But the best part is these elevations. So I also have downloaded the elevation for this area, and here we have a large variation in elevation. So as you go towards Mussoorie in the north, you are seeing heights of about 1500 meters. And if you come down south, you see nearly 400 meters. So very large variation in about 1000 meters in elevation. And if I had to see this in 3D, it appears very nice. Let me just reduce the exaggeration. Yeah. So I hope you can see this. So what you're seeing is basically the false color composite of Dehradun city, which is draped over the digital elevation model. Towards the north, this is the north here, is the Mussoorie Hills. And towards the south, this way you go, you'll reach Haridwar. And if you come this way towards the west, you'll reach, you'll go to Saharanpur and Himachal Pradesh. So very nice, beautiful visualization. You can see the forest in the south, You can see this dense urban area, and then you can see agriculture happening, the river channels, and these are all seasonal rivers, only have water in the rainy season, and so on. So the idea of showing you is that we can create these false color composites from satellite data, digital elevation, from the internet, and we can create our own data set. Now, for example, so enough with the 3D thing. Now let's create some own maps. Let's create a map. Yes, of course, very nice visualizations, but eventually what we would like to do is create a map for publication or something. So beautiful maps can be created using QGIS. This is a very simple example. And thankfully, since we have this lecture today, I have the pleasure of showing you a paper that got recently accepted. And we have made all the maps in this paper using QGIS. So I hope this is visible. So this is a map of a data set called Nightlight. This is what you see the world if you're looking in the night from space. So you can see these two cities, Lucknow, Kanpur, Noida this side, and Prayagraj and Varanasi. These are all appearing as lighted. So I'm not talking about night light, I'm talking about the quality of maps that can be prepared using QGIS. We have the India map, we can create insets, we can create legends. Let me show you more complex maps that we created. So these layouts having multiple maps on them, having showing land use, elevation, slope, road type, road density, and so on. So these are different phenomena. We got it from different sources, but this map has been made using QGIS. So that is the important thing which I'm trying to highlight. Even more, I think I have more advanced stuff like, just a second. Yeah, this map. This is done using QGIS, not in PowerPoint and in anything. Pura full thing in QGIS, where we are showing one type of data, different zoomed in insets on the first column. Then second column has a different product for these areas, Lucknow, Agra, and Prayagraj in these insets, and then two other modeled products in these columns. So the idea is very advanced maps can be created in GIS and they can be published. This is a published paper in a very reputed journal, which has just come out this week. And I am happy to tell you that all these maps have been prepared in QGIS. So, so if there is somebody in your group who's saying, no, it is a bad software, you cannot publish your maps, then you ask him to talk to me. Okay, so, because I have real life examples of how this software can be used to make maps. Basically, the information should be correct. Information should be correct, it should be decipherable, it should be understandable, and the editor doesn't worry about whether you've used software A, B, or C to prepare it. Okay, at the end of the day, it is an image. So yeah, I took that opportunity to tell you about one paper, but the idea is that map, this map, everything is made in QGIS, and I'll show you in the next maybe half an hour or so. I have half an hour, yeah, to how you could make it yourself. And if Madam allows me, I will share this file, which has step-by-step instructions to make that map, the final map, with you guys. Okay.
Yes, sir, definitely, sir. You can mail me. I will share to the participants, sir.
Right. Thank you so much. So everything that I'm doing here is detailed here step by step. You have to download and install QGIS, download the district boundaries from here, add the satellite data and show it. Okay. So we'll just follow this and do it so that you can do it yourself after this lecture. So, so you saw how you could download and install QGIS from this website. Next, you need some data. So the starting point I would like to share is a district map. Now, before I start, again, this is something which I have faced in many sessions. But in India, to get data, especially boundaries of anything, let's say for India boundary or district boundary, state boundaries, the only authentic source is Survey of India. You can get several others from different sources, but if you say legally or the most authentic thing is from Survey of India. Okay. Then there are many other people, even if you type in Google, give me district map of India, District of India shape file or something, and there will be several sources, ArcGIS, then Kaggle and MIT and all, but these are not, I mean, you cannot like, so somebody could challenge you whether this is correct or not. Okay, so the data I am showing you is not the correct one from Survey of India. It is just a toy data set. It is just to show you how we can add some vector data in GIS. Okay, don't fire me saying that this district map is wrong, because it is wrong. If you look at it carefully, you will see that this mass generalization has been done. But it is just to show you how to add data in GIS. Okay. So how do you download this data? Simply click on this link. Once you get this file, you simply click on it. It will open a browser and you will see some numbers which are displayed. Abhi hona hai isko. So my browser wants to update right now. So we'll wait for 2 minutes. Oh my God. Murphy's Law. So once you click on that link, it should show you some numbers on your screen. Okay, don't worry about that. Just press Ctrl S on the keyboard and you can save this file. So I'll go to today's folder and I'll QGIS demo and I'll save this. Okay, just press Ctrl S and save it. In your folder, you will see that a new file has been created, which is called India_district.json. Now, JSON is a more new format, I would call it, more popular nowadays because this is a more easier to.
Hello, sir.
Yes.
So in QGIS, how you selected 3D model, sir? Can you show here?
Using one plugin called QGIS to 3JS. Okay, I'll just show you that link. Called plugins. You can hear me, yes? Yes, okay. In QGIS, we have something called plugins. You can go to plugins, manage and install plugins. Here we are using one plugin called QGIS to 3JS. Here 2 is a number and 3 is in words. So QGIS to 3JS, this plugin I am using to make all the 3D visualizations. I am not making the 3D model. Making a 3D model, you require something like SketchUp or AutoCAD or something. If you get those 3D model files, you can visualize it using this QGIS to 3GIS plugin in QGIS.
Okay, sir. Okay.
Right. Thank you. So, कहाँ थे हम? We had downloaded our file indiadistrict.json, and in QGIS you can add several types of files. So there is something called data source manager. If you click on layer, the first option is data source manager. This allows you to add several types of files. First one is a vector file. Second is raster. Then there is a new format called mesh. This is something like netcdf files. You can also add text files. We will also see how to do this. Yesterday, Ashutosh Jha was talking about a geo package format that can be added. Spatial Light, you can connect to different databases like Spatial Light, Postgres, MySQL, Oracle, DB2. These are all different types of databases. Then you can also add some web maps. We will see how to add one. Web map today. These are maps which are published on the internet and you can consume it. The word they use it, consume those web maps in your GIS and so on. These are all web-based maps. So first, let us add the vector data that we have downloaded. So you click on vector, you click on this browse button, you go to today's folder, and you will see there is one option which says all files. You will see that there are several types of files that can be added. Your AutoCAD DXF files, your ISRI shape files. If you have a GPS device, a GNSS receiver, something like Leica or Magellan or Garmin, then the file which is created is a GPX file. That can be also added. GeoJSON, the file that you create in Google Earth, KML, that can be also added. And many others, several formats can be added. So we will just select this India district, click on open, click on add, and close this window. We see the India district map. Again, this is the incorrect India district map. This is just to show you how to add vector data. I know it is incorrect, but this is just to show you how to add some vector data. So this is the layers panel on the left hand side. You right click here, you will see several options. We will go to this option which says open attribute table. Here you see it says there are total of 645 districts, and the first column is district, which has the district names. The third column is called ST_name, which is the state name. So if you click on the name of the column, it will get sorted. If I click on ST name, I see first it is Andaman, Nicobar, Bihar, Haryana, and so on down to West Bengal in alphabetical order. Similarly, if I click on district name, I see Alibad, Agra, Ahmedabad. This is in alphabetical order right down to Y and Z. Fantastic. So this is what the attribute table looks like. You can select the rows directly from here. If I click and drag my mouse, I can select these rows. These are the first 10 rows when I sorted district in alphabetical order. If I want, let's say, there is a button to deselect them. If I want all the districts in Andhra Pradesh, Andhra में बहुत सारे district हैं. Let's take Chhattisgarh. So yes, it says 18 districts have been selected. Bastar, Bijapur, down to Surguja and one more. So, so this way I can select different features just by visually seeing the attribute table and the map together. and I can right click on the name of the layer and export the selected features as a new file. मतलब इसमें से काट के मैंने उसको एक नया फाइल बना दिया. I took out the districts and I saved it as a separate file. Now for today's exercise, I will deselect everything. I will show you also how to run a attribute query. In the book, it is also mentioned as non-spatial query. So there is one small icon here in the attribute table. It looks like an inverted summation sign, or it is the summation sign. If you click on it, another box will open up which says select by expression. So we'll write an expression like wherever the district name is equal to Bilaspur, you select that district. Okay, you can use several types of query operators. So we will say district. I expanded this column which says fields and values. District, I am just using the mouse, not typing in the keyboard, is equal to, and then I click here, all unique. So it is showing me all the unique district names. So I scroll down and I say Bilaspur, or I can simply type here Bilaspur. Okay. And I will say select features. I click on this select feature button. You will see that it says here 2 selected. Why is there 2 selected? Because there is another district in Himachal Pradesh which has the same name. So you see one small yellow dot is here and one yellow polygon here. So these are the 2 ones selected. I'm just interested in the Bilaspur Chhattisgarh district. So I can press Control and press this row, Himachal Pradesh, and it will get deselected. So I have just this one feature and I want to save this as a separate file. So I'll right click here, export, save selected features as, give where I want to save it. So I will go to again today's folder and I will say this is the Bilaspur district boundary. First drop down says history shapefile. So what is happening is we added a JSON file, but now I am saving a part of it as a different format. So I am also doing format conversion, JSON to shapefile, and from India down to Bilaspur. That's it. Just tell where to save it and click on OK. And it will add this new layer. If I turn this off, it will add the district boundary. I can right click and say zoom to this layer. And now I have the district boundary of the Bilaspur district. For my purpose, I don't require the India district, so I will remove it. So I can just right click on the name of the layer and there is an option which says remove layer. I can just remove it. So first thing that we have successfully done is we have downloaded one vector file, we have added to GIS, we have run a non-spatial query, that is an attribute query, and we have saved the selected features as a separate shapefile. Okay. Again, all these steps are listed here, just step by step with screenshots. So I don't think you should face any problem. And how I can save it and remove finally the India district file. All this is given step by step. Okay, next thing that I want to do is I want to change how it looks. So layer styling is one very important thing. How this thing looks. I want a different color, or I want a different color, something like red, or I want the boundary to be dotted, or sorry, let's say this to be filled in hash or solid colors, and the boundary to be dotted. If you see, these are now Let me just make it transparent. Now you see the boundaries are now a dashed line or dot lines. So this is may not be visible at your resolution, but this is changing. The type of line is changing by changing this stroke style in this layer styling panel. Okay, so but for today's purpose, I'll show you a new thing which is called symbolizing it in a. So if you have different, let's say different districts, you can symbolize based on separate categories, let's say name of the district, or if you have land use, then based on the land use. If you have some number, let's say temperature, population, then you can create it. Then you can create graduated bins. So all these are different types of styling. Single symbol is for single color for everybody. Categorized is based on categorical values. Graduated is based on continuous values. And then there is one called inverted polygons. Let's see what this does. If I select it, you see that the color that I chose is now filled outside throughout the map. Only inside it is transparent. Okay, so I'll tell you why I'm doing this in the next step. But right now you just see that there is an option which says inverted polygons, and whatever color I give will be filled outside. So I want to keep that as white only. I don't want to give it a different color. So you'll say it looks the same, but actually inside it is transparent and outside it is white. You will see how it helps me. Okay, so this is about layer styling. This is an exhaustive thing. You can change colors, you can add multiple symbols, you can have, you'll see, you can change the type of the line, the type of filling you want, and so on. And several places you can write code also if you want to like improve the visualization. Next thing we'll add is some satellite data. Now, I showed you how we can download the false color, the list 3 image from Bhuvan. We can create a false color and all that. But of course, you'll have to create an account, you have to download it. In Bhuvan, it is given in small tiles, so it is easy, less than 10 MB. But if you download from USGS, it is about 300, 500, even MB, even 1 GB sometimes. The recent one, Sentinel data is huge files, 1.5 GB and so on. So I don't have the patience and we don't have the time right now in this session to download that file and show you how to do it. So we'll use something called as a web map. What is a web map? Web map is nothing but any map that you see on the internet, something like Bhuvan. You are seeing a map which is coming on the internet. This is coming directly from the Bhuvan server to my browser. Can I bring this map in GIS? Okay, to do that, we need something called a WMS server link. This is a WMS service, and even here, I think you can add your own WMS services in Bhuvan also. But that is not the point. Point is, they also publishing some, there is something called Bhuvan Store here. You click on it, you will see if you go to the bottom that they have WMS services. I'll just zoom in a little bit. They have WMS services for several things: land use, land cover, uh, land degradation, urban land use, wasteland, and so on. So these are fine, but for this example, I'll not show you Bhuvan. I'll show you a Sentinel data set. What is Sentinel? Sentinel is a satellite from the European Space Agency, and somebody, Sentinel, has made a very nice web map using the Sentinel data for the whole world for different time periods, 2017, 18, 19, and so on. So this is the website that helped me get this. This is s2maps.eu. This is basically Sentinel cloudless data, which looks something like this as a web map service. So I don't have to download it. I just need to be connected to the internet. And if I use their WMS service, I can get that map directly in GIS. Okay. So how does this work? So we'll go back to our PDF file. Here it says, click on the layer, add WMS layer, and you paste this link. So I'll just copy this link from here, Control C, and I will go to QGIS, layer, add WMS layer, or from my data source manager, WMS, new, I need this link in URL, let's call it Sentinel WMS. And that's it. Just click on OK, click on connect. Since it is coming directly from the internet, it will take some time, 10-20 seconds, depending on the speed of your internet connection. And you will see that several layers are available, several layers. You can experiment with some of them after this session. Right now, we are going to use this one, which says S2. S2 stands for Sentinel-2 Cloudless 2019. This is the latest cloudless composite for the entire Earth. So we'll just take this, click on add, and then click on close. So you are seeing this beautiful satellite image in natural colors. So this dark green is vegetation, this blue is a very large reservoir, probably a dam here, so on. But now these are in GIS, everything is a layer, one top of the other. And I can change the ordering. Now we had the district boundary. The Sentinel has come on top of it. I can click it and bring it down. Simply drag, nothing technical. Just click and drag this down and leave your mouse. And now you see, remember we had changed this to inverted polygons. Everything outside is white and inside it is transparent. So what appears is that now we have the satellite image of just the Chhattisgarh district with us. But actually it is coming directly from the internet. So you will see this streaming kind of thing happening as you zoom in and zoom out. So this is a town, there's probably a stadium here. This looks like the railway station, some planned garden or something, and then the city and so on. So very interesting. Now I have the raster data, I have the vector data. Next thing I want to show you is how to add your own data. Let's say you have some data in form of point coordinates, like you want to map all the schools in the region, or all the police stations, or all the guest house, forest guest houses, any government institution you want to map. So how will you do that? You must require coordinates. How will you get the coordinates? You require a GPS receiver. If you have the GPS receiver, great. Something like Garmin or let's say GNSS receivers handheld. You require some receivers like this, Garmin or Leica, or there are several companies which sell this. Or if you don't have time to buy it, you can simply install an app in your Android phones. GPS tools. Just install it, start it, and hopefully you should be able to go in the field and take the coordinates on the field. So you start the app and you get the, sorry. Yeah. So you have the coordinates and the altitude, some address, even some accuracy measure also. So if a few meters of error is fine, then even a mobile app is enough. Depends on what is your accuracy requirement. If you are into tax collection and all, even an error of 1 meter is lost to the government, then this is not enough. Then you require a proper, accurate GPS device, which could cost you lakhs of rupees. But if you just want location of a place, a few meters of error is fine. Raste ke is par ya us par bhi chalega. Then this is also enough. A mobile app is also good enough. Anyhow, even if you don't have time for that, there is COVID, you cannot go out and you cannot go to that location and take the GPS reading. No problem. There's another easier solution for you. Just open the Bhuvan Maps or Google Maps and you go to the place where you want. So let's say I want to go to DC Bilaspur. So it says Government Engineering College. Okay. Hopefully this is your college. And I'll click anywhere here. Sorry, let me click anywhere here. And it shows me the latitude and longitude right over here. Okay. So 22.13 degrees north, 82.13 degrees east. All I need to do is copy this, open your simple notepad, nothing technical, just paste it here and give the name of the place, let's say GEC Bilaspur. Okay, separate all the fields by commas, give a header, let's say name, latitude, longitude. You can have multiple rows. Let's say you want some other information, let's say police station, some other coordinate, something. I'm just giving some random values, okay, or hospital, and so on. So you can have multiple. My idea of selling is that you don't need separate files. You can have a single file with multiple rows separated by commas. Save this. Let me save this in today's folder. Let's call it college coordinate as a text file. Yeah, text file will also do. Just make sure that all your fields are separated by these comma symbols. And inside this, so if this is your name, there should not be any comma. Then it will be interpreted as two columns. Okay. So just don't give any commas here. That's it. Just save this information. Go to GIS, your data source manager. There is an option which says delimited text. Browse for today's file, that is college coordinate. Click open, and hopefully it should fill all the values by itself. So now it knows that it is a comma separated values file. That is, the values are separated by commas. It is having point coordinates. The X field is the longitude. The Y field is the latitude. And that's it. Just click on add and close. So what it has done, it has converted that notepad file into a point shape file. It's like a shape file, not exactly a shape file, but it is a point coordinate. It's a vector data for us. I want to symbolize it better. I want it to look nicer. So I'll make it a larger symbol, something like this. I can add some label to it. The name is the label. I want to make it visible on this background. So I'll make it yellow. So there are several options here. You can change the font. Let's change this to Times New Roman. I want to make it larger. I want to make it a different color. Let's say yellow. I want to make it bold. Yellow because it will be visible on this background. and the placement is not right. It is overlapping this symbol. So there are several options. You can change formatting, draw a buffer, something like this around the words. You can draw a background, or you can place it anywhere, top left, top right, left, right, so on. So I'll just place it on the left and I will offset it a little bit. So maybe -4 or something. I want to shift it to the left side. So it is right next to the college. I also want to put the name of the district here. So we'll put a label to the district boundary. So it has come, it is in black, so it is not visible. So let's make it something more fancier. Let's say monotype cursiva, large, and let's draw a buffer around it. Of course, Prasun sir, you're doing very fast and all. Don't worry, everything is written step by step in this file. You don't have to worry about. So I have the name of the district, I have the point coordinate, I have a vector file, I have the raster layer, everything is there. All I need to do is make this layout. It is called the map layout. In QGIS, it is called the print composer, okay, or print layout or layout, yeah, print layout. Before I go there, let me just save this project just in case. So let's say my project. So just in case QGIS decides to crash on me today, I can just simply click on this file, my project, and it will open all the layers, all the symbology, everything will remain the same. Let's do it and see. So I have clicked on new project, I have removed everything. Now I click on project, open, click on my project, click on open. And now I have my layers, everything is same, just as I left. Okay. Now we'll make a layout, we'll make a map composition. I still have loads of time left. Yeah? Okay, so we'll go to new print layout. This is the paper on which your map will be prepared. You can change the shape of the paper. Generally, it is A4 landscape, but if you want a larger map, A0, poster size, diwar pe lagana hai. You can make that, you can make smaller maps, anything. You can change these numbers manually also. Okay, so I'll just keep it like this. It is A4 landscape. What you can add here, you can add several things. You can add a map, you can add pictures, labels, legends, scale bar, north arrow, and several other things. And this is a very fully functional map composer. Too many options for anybody to know in one day. So let's add the map. Whatever is being displayed here will come on this map composer. So we'll add a map, add map, click and drag the area where you want the map to be. So I'll just drag this area from here to here, and whatever was displayed here should come right on my page. I want this map to be shifted little to the left. So there is a move item content. Click and drag here and unselect it. You can set the scale at which you want the map to be. So I will say I want it at 7,50,000, or let's say 7,50,000, 1, 2, 3. So I have set the scale. Maybe I want it at 8 lakhs or 7 lakhs. Anyhow, we will keep it at 7.5 lakhs. Okay, next what we want it to have a grid. Grid is the line around it. So we'll add one grid. At what intervals do you want that grid? You want it at every 0.2 degrees, so many lines, or you want it at 0.5 degrees, half a degree, in X direction, in Y direction. Lines are too bold. It should be light. So we'll change the line style. We'll make it of a lighter color, let's say gray, and make it thinner, maybe 0.2 mm. Okay. So I have made the grid lines, but I want a frame around it. So there are several types of frame. You can have a zebra like this. You can have simply a line border. You can have ticks, interior and exterior ticks, lines. These lines are called ticks. So we'll have a normal zebra. You can also change the colors, the thickness, too many things that you can do. I'll just choose the vanilla options currently. Next, I want the coordinates to appear on top of these grids. What is this line? What latitude, longitude? So I'll say draw coordinates. Now, just I'm zooming it so that you can see what changes I'm doing. What format you want, whether you want decimal with suffix, with degree east, degree north, whether you want degree and minute, 83 degrees, 30 minutes. So I want degree minute with suffix. I want 83 degrees, 30 minutes east. But I don't want these 0.000. So there is an option to reduce the precision. I want to reduce it to 0. I don't want these numbers. I just want 83 degrees, 30 minutes east. That is good enough. These numbers, I want it standing, not horizontal, vertical. So the left and right coordinates, I will make them vertical ascending. And that's it. I wanted the font to be a little bigger. So let's change it to Times Bold 10. 10 is enough. Yeah, 10 is enough. So very well. Let's make it a little bigger only. Yeah, I have my coordinates. I have my map. I have my raster data, district name. Everything is there. What next? Let's add the scale bar. So there is item. We'll go serially. Let's add map. We did. Let's add a picture. So I'll drag the area where I want the picture. You can add some symbols, or you can take an image which is stored in your system. So I went to Google and I asked him, okay, give me an image of Bilaspur. Easy Bilaspur. This one only. No, I think I went to your website. The website का भी link इसी में है. Yeah, go to your website. There are several images. I take one image and I save it to my computer. I think this is the photo. Yeah, this is one photo I got from your website. Okay, so this is a normal PNG image, JPEG image. I'll add this to this map here. So normally when you're making a map, let's say forest, then you would like to add some animal or bird pictures which are available in that region or things like that. So you can get creative with what you want to do. So I'll just add this photo here. So there you go. I can make it big, small, add a boundary to it. I'll add a frame around it. Okay. And let's add an arrow. Let's add an arrow from this image here to this point here, just to tell, okay, this is where the college is. Let's make it some other color, a little thicker. Yeah, I think that should, I want the head also to be. I want everything to be yellow so that it is visible in this background. So I have an arrow pointing to the college. This is the photograph of the college. And I want I want to add a north arrow here. Okay, next item is add, okay, let's go to add north arrow directly. Let's drag and drop this area. So it will add a north arrow. You can also, if you wish, you can change the colors inside this north arrow. That is also possible. Let's add a scale bar. So I'll just click here. There are several types of scale bar. Double box. Let me zoom and show you these different options. There is single box, double box, middle ticks, down ticks, up ticks, step line, hollow, numeric, so many. We'll take a simple one. Which looks like a double box. Yeah, this is fine. 0 to 50 kilometers. Okay. This solves my purpose, but of course you can change these units. You can change the number of divisions you want. 5 divisions, 1 division, all this. You want to change instead of 0, 25, 50, you want 0, 50, 100 or 0, 20, 40. All these you can change according to your needs. I want these numbers to come down. I think I have done that. Labels are below the segment. Oh, wow. So I have my scale bar, north arrow, image, map, grids, almost everything. Just a title would complete the map. So I add a title here. Let's call it satellite image of Bilaspur and location of DEC. Just increase the font. Let's make it large. Fantastic. So I have this title almost completes my map. Of course, there are so many options. Depending on how much time and patience you have, you can make it more beautiful. I showed you some examples of maps that I have created in QGIS, pretty advanced maps. And once it is done, the next thing that you would want to do is export it. So you can export it as an image, a JPEG file, or a PDF file. Let's export as a PDF file. So let's call it my map. And on save, it will take some time. And once it is done, it will give a prompt saying the save is successful. So in your folder, it should create a PDF file by the name my map. It is creating it currently. Sorry. Fantastic. So I got a prompt saying export layout, successfully exported. I click on this link, it will take me to that file. Just open it in my PDF. Okay, some PDF, some issue was there, but with WMS layers, it is giving some issue with PDF. But if I export to image, the first thing it will ask me is, let's call it college map. It is what DPI, what resolution you want. So depending on where you want to print it, you want to print it on your wall, then you must have high resolution, maybe 1200 DPI or something. Of course, you are seeing that the number of pixels are increasing. If you want it in a report, even 90 DPI is good enough. in a simple printout. 90 dpi is good. Today we'll just print it at 150 dpi. Click on save, and it should create a college map PNG file, and there you go. So I have created this entirely in front of you in QGIS. Similarly, you can create wonderful maps in QGIS. So too much of QGIS. One last thing, please bear with me. One last thing I'll show you. There are several things that you can do here. And this technology is going so fast, if you don't catch up, you'll get left behind. There is something these days, the cameras that you have, digital cameras, even smartphones, they are capturing different kinds of metadata. You have seen some places that it says whether you want to geotag the photo. Okay, so this photo was taken in 2016. All that information is there, but it also has the location of this when this photo was taken. Not only that, the newer cameras are also telling in what direction north bearing were you standing when you took this photo. So the compass direction is also embedded here. Now, can we use these photos as input to GIS data? These are nothing but points, no? Can we add them to GIS? So there's something called the processing toolbox in QGIS. This is where all the GIS tools are there. You want to do your geoprocessing like clip, buffer, dissolve, geometry operations like centroid, polygon to line, triangulation, everything is there in QGIS. There is something called import geotagged photos, a tool called import geotagged photos. So double click on that, specify the input folder. So I'll specify where have I kept it? Yeah, this is the folder where have I kept it. And that's it. Click on run. You will see that it has converted those points, those photographs into points. There were how many photos? 6 photos, and I have seen 1, 2, 3, 4, 5, 6 points. If I click on this I button, if I click on any point, and if I click on this box, feature attributes, I can see for this point, this is the photograph. This is the altitude when I was standing. This is in a place called Company Garden in Missouri, which is at the height of 2011 meters. I was facing 188 degrees from north. This is the lat and long, and the timestamp when it was taken at 4 in the evening on 3rd March 2016. So much information is there in these photographs, and you can use it like spatial data. It's very useful in forensics and several other things. But yeah, so I have these points. What I can do with these points? I know the time when it was taken, so I can create a route. Okay, so there is points to line. I say take the point layer based on the timestamp. You create a path that I took. So I first landed here. I took this photo. Then I went here. I took another photo. Then I went here, and so on.
Sir, actually, the screen has paused, sir, and there is no movement in your screen.
Did you guys pay for Teams or is the free version?
No, sir.
Sir, it is going actually.
Okay, I'll reconnect. Okay, can you see this now?
Yes, sir.
Deepti.
Okay, so we'll use this. So now you saw how we can add some photos and create points out of it. I can join these points to create a path based on the timestamp variable. So I took the photos, I took the timestamp, and I click on run, and I see a path is created. So I first went to this place, took a photo, then went to this place at the next time, took another photo, and so on. Now, I told you I have the compass bearing, so I can create something called wedge buffers. Now, buffer you have heard, okay, circular buffers you can create. But I want to create triangular buffers based on where I was facing when I took the image. So I was facing in this direction variable, and just wait a second. There are a few options which have to be specified here. I will just 0.0001. Okay. So the length of the has to be how big the triangle is going to be. You specify in degrees, and that's it. You click on run. Now you know. I took this photo. I was facing in that direction. Then I took this photo. I was facing towards the northeast. Then this photo, and this photo, and so on. And when you click on any point, you can also see what is the photo taken at that point. So, sorry. Okay, so yeah, so all this can be done in QGIS and several other things. I cannot stop showing you what are the various things you can do. Recently, we've also created some time series animations of, let's say, COVID cases, and where will I get that? I don't know. I have kept it somewhere. I cannot find it right now, but yeah, but there are several things that you can do. Recently, they've also come up with this temporal controller where you can have time series data, and it will change. You can set what time range you want the data, and it will change something like temperature, rainfall, and all that. Or even, let's say, you have some timestamp movement or COVID cases, and all that can be visualized and changed with respect to time. So yeah, basic stuff like making maps is also there. Advanced stuff like making space-time animations, creating these wedge buffers and all. Several things are available. If you are teaching your students remote sensing GIS, and if you think that you need lakhs of money to teach them GIS, no, you don't. You go to this website, download QGIS, and you look at my tutorials or any of the tutorials on the internet. If you are not comfortable in English, you are comfortable in Bengali, type YouTube QGIS Bengali. And there are several videos in on the internet where people are teaching you QGIS in their language. So I will conclude here, although I have some time, but I'll like to take your questions if you have any queries, how we could do this or things like that in QGIS, that I would be more happy to take. Right. Thank you.
Very good afternoon, sir.
Good afternoon.
Sir, if I have a latitude and longitude of various locations in Bilaspur, And if I am trying to locate the groundwater quality of those locations, okay, so can I?
Please repeat from the start. I think I lost you something.
Okay, so suppose I have values of latitude and longitude of various groundwater locations, okay, groundwater sources. Now I just want to locate the various locations in a single map where I can show the location as well as the quality of the groundwater of those places. So is it possible to do it through QGIS?
Yes, sir. So
Okay,
you are very lucky. Today I have a lot of time, so I will do it and show you.
okay,
Okay.
please.
चलिए, आपको ऐसा टीचर नहीं मिलेगा, मैं आपको करके दिखा रहा हूँ, आपका प्रोजेक्ट आपके आंखों के सामने. So let's add that boundary file to start off. ठीक है, ये मैंने डिस्ट्रिक्ट बाउंड्री ले लिया. अब आपने कुछ पॉइंट्स कलेक्ट किए हैं फील्ड में, ठीक है. So you have taken some.
स्क्रीन शो नहीं हो रहा है सर, ये पता नहीं पॉज हो गया है स्क्रीन एंड ओके नाउ इट इज शोइंग सर.
So you have gone to the field and you have taken certain points. Okay, just for sake of ease, let me take 2-3 points. Okay. So पहले समझिए हमने यहाँ पे point लिया. I'll just type it in the notepad. You will have this data in Excel or something. So I have 82.131, 21.966 और आपने यहाँ पे समझिए वाटर टेबल मापा. लेट्स से 10 मीटर पे वाटर टेबल है, ठीक है. फिर आप कहीं आप क्वालिटी ले लो, वाटर टेबल डेप्थ ले लो, सब कुछ सेम है. इट इज जस्ट अ नंबर. Then I went to another coordinate, let's say 81.717, 22.184, and then I measured here the water table is, let's say, 15 meters. Then I went to the north, and here I took another point, let's say 82.027, 22.851, और यहाँ पे वाटर टेबल ऊपर आ गई, लेट्स से 5 meters. Okay. So ये डेटा आपके पास एक्सेल में होगा, just put it in notepad or something, and you write a header. This is longitude, this is latitude, and this is the depth in meters. Okay, let's save this file. Let's call it groundwater और या वाटर टेबल, कुछ भी नाम दे देते हैं.
आप कोलिनाका पे पहुंचेंगे तो मेरे को एक बार कॉल कर लीजिएगा.
ठीक है. सो वाटर टेबल के नाम से हमने स्टोर कर दिया, इसको बंद कर देते हैं. अब इसको ऐड करते हैं जैसे पहले बताया था. डिलिमिटेड टेक्स्ट फाइल, विल गो टू दिस फोल्डर वाटर टेबल. ठीक है, it has automatically read everything. Just click on add and close. Now I have my 3 points where the water table information was taken. I want to display just the water depth at these points. So I know that it is 5 meter, 15 meter, 10 meter. But that is not enough, I know, because next step you will ask is, how do I interpolate for the entire region? How do I create a water table map? So what you have to do is interpolation. There are different types of interpolation techniques. I'll use the simplest, IDW. This is basically gives weights to the value and inverse weights to the distance. मतलब किसी भी point पे, if it is predicting a new value, it is giving highest weightage to the closest point and lowest weightage to the farthest point. So we'll say water table is my vector layer, depth is my interpolation attribute, and extent I want to have the district boundary, What is the pixel size? I want, I'll take 0.01, or you can give in kilometers. This is in degrees, so this is roughly what, 1 kilometer ka pixel size. You can change it and then click it run. I think that is all. I don't know what I will get. Oh wow, wonderful. So now I have, मैं आपको दिखाता हूँ. So I have the groundwater table map. This is the groundwater table map. Here, obviously, these are the colors that you don't use. You use something like blues or even spectral. जहाँ पे पानी ऊपर है उसको आप ब्लू बताएंगे, जहाँ नीचे चली गई है उसको आप रेड बताएंगे. तो ये बन गया आपका वाटर टेबल मैप मुफ्त में.
Okay, thank you, sir. Thank you very much.
Yes. So it is very simple. You just need to know how to use these tools. I did everything that I told you. I added one raster, I added one point. Only thing new is I did some interpolation. And then using raster, I symbolized it such that it looks more like. Okay. Any other thing you want to ask? ये कैसे करना है? मेरी PhD कैसे निकालनी है? ऐसा कोई क्वेश्चन?
सर तो इसमें तो हम लोग सिर्फ और सिर्फ न्यूमेरिकल वैल्यू शो कर रहे हैं. अगर मान लीजिए जैसे उसका यूनिट रहा, ओके, जैसे आप पीएच है तो पीएच में तो कोई यूनिट नहीं, और भी कुछ जैसे पैरामीटर्स हो गए, मिलीग्राम पर
पीएच तो न्यूमेरिकल वैल्यू है ना भाई.
हाँ सर, लेकिन और अदर पैरामीटर्स हो गए जिनमें आपका जैसे मिलीग्राम पर लीटर में कुछ कॉन्सेंट्रेशन है, तो वो उसको तो हम लोग वहां पर नहीं शो कर पाएंगे ना सर?
नहीं, पहली बात दो चीजें. एक तो कॉन्सेंट्रेशन भी न्यूमेरिकल ही होता है. ठीक है, आप जो पूछ रहे हो मैं बताऊंगा. आप जो पूछ रहे हो मैं बताऊंगा कि आप कैटेगोरिकल वैल्यूज कैसे दिखाएंगे. लेकिन जो आप कह रहे हैं वो एग्जांपल सही नहीं है. कॉन्सेंट्रेशन भी न्यूमेरिकल ही होता है. सम मोल्स पर डेसिल, कोई एक मोलार कॉन्सेंट्रेशन होगा या कोई एक ppm में कॉन्सेंट्रेशन होगा. दीस विल बी नंबर्स ओनली. बट लेट्स से आई हैव सम I know, let's say groundwater divisions, कि भाई 3-4 लोग हैं जो अलग अलग डिवीजन देख रहे हैं. ठीक है, so I have let me create a new map. Let me save this. Save features as, let's call it groundwater divisions. ठीक है, और इसको मैं अलग अलग डिवीजन में बांट देता हूँ. इसके लिए मुझे चाहिए एक डिजिटाइजिंग टूल बार. समझिए ये 4 डिवीजन में मैंने अपने डेटा को डिवाइड कर दिया. ये मेरे 4 डिविजन्स हैं और इसके ओनर्स अलग अलग हैं. लेट्स से फर्स्ट वन इज, फॉर एग्जांपल लेट्स से इट इज, कौन सा है, साउथ वेस्ट. लेट्स कॉल इट साउथ वेस्ट. ये कोई एजेंसी है जो साउथ वेस्ट देखती है, ये एजेंसी नॉर्थ देखती है, ये एजेंसी सेंट्रल देख रही है, और ये एजेंसी साउथ ईस्ट देख रही है. सॉरी, गलत लिख दिया मैंने, साउथ ईस्ट. ओके, नाउ आई वांट टू शो इट इन डिफरेंट कलर्स based on their on the division which is taking care of it. So there is something called categorized. Categorized based on what? Based on the divisions. तो अब मेरे पास अलग अलग डिवीजन आ गए। जैसे आप कहना चाह रहे हैं कि इसमें इतना डिसिलीटर कॉन्सेंट्रेशन, बट ऐसा होता नहीं है। नॉर्मली एक वेरिएबल थिंग है, रेंज में आएगा। तो anyhow, so if I have data which has a field which has separate categorical values, they can be used to make. Similarly, you can change these colors. You want to, some papers only want black and white images. So you want to give something like this, hashed symbols. Some will have vertical, some will have horizontal, some will have dots or diagonals and so on. So ऐसे करके you can change the type of outputs. ठीक है। Now if अगर इस कॉलम की जगह आपका कुछ और वैल्यू होता तो उस पे भी हम कैटेगराइज बना सकते थे। Let's say two people are taking care of the same zone. Let's say there is one agency which is taking care of both of these. So we just write the same name and automatically you will see that the symbology will be made uniform. देखिए अब ये दोनों same horizontal lines होंगे. So if you have any other categorical और graduation continuous data का difference देखिए, आपको आंसर मिल जाएगा कि जो मैंने बताया उतना काफी है, उससे ज्यादा नहीं चाहिए।
Okay, thank you, sir. Thank you.
Thank you, sir, for all the beautiful demonstrations. Actually, we have a question posted in our WhatsApp group. The question is something like, Prasun, sir, can you please mention few mistakes that we generally see while...
I am not able to hear you.
Okay, so you are not able to...
Can you repeat?
Okay.
Yeah, now I can hear you.
So one of the participants posted a question in the WhatsApp group. The question is like, sir, can you please mention few mistakes that you generally see while reviewing papers, or in general errors that researchers knowingly or unknowingly make while presenting their research work in an international journal? This will help us avoid those mistakes in future. Thanks in advance.
Very good question. ये पढ़ाने से नहीं पढ़ सकते. You have to learn it by doing it. But still, I'll answer your questions. With respect to maps, let's first talk about with respect to maps. Then, in general, about the manuscript, I can give you some tips. Many times, maps are very bad. There is no other word for it. मैप एक मीडियम है, इट इज अ कम्युनिकेशन मीडियम. जैसे मैं आपसे बात कर रहा हूँ, मैं स्पीच बोल रहा हूँ, अभी मैं करूंगा तो आपको भी नहीं समझ में आएगा, आप भी बंद करके चले जाओ. Whatever you want to show, you should show that such that the person looking at it should be able to understand that information. अगर मैं यही GC बिलासपुर को 4 फॉन्ट में लिखूं और काले में लिखूं तो वो दिखेगा ही नहीं ना. So whatever you are trying to show should be visible to any viewer who doesn't have any knowledge of this area. So remember, a person who will be viewing or reviewing your paper may not have come to your study area or may be very knowledgeable of your study area. Okay? In either case, if you are not conveying your information correctly, then it is not right. It is prone for rejection. Okay. So whenever you are showing any information, make sure that it is visible, and you yourself, your friend who is from, let's say, different background altogether. Maybe you are in civil engineering, maybe he is an art student. But while looking at the map, he should be able to understand what the map is. He लिखा है यहाँ पे satellite image है, देखिए satellite image है. ये GEC बिलासपुर मुझे पढ़ने में आ रहा है. These are coordinates NE बहुत बार लड़के यहाँ पे बहुत सारे डेसिमल प्लेस छोड़ देते, जैसे मैंने इनिशियली दिखाया आपको 3 डेसिमल प्लेसेस of zeros. It makes no sense. Does that zero convey any information? Whenever you add any information on your, or if there is anything on your map which is not showing the information that you want to tell, remove it. अगर इस मैप में कुछ भी है जो आप नहीं बताना चाह रहे हो या जो नहीं होना चाहिए, वहां पे आपका वो फोकस ही नहीं है, आपका फोकस है मैप दिखाना, अपना डेटा दिखाना, you just keep that, you remove everything else. That way you are only highlighting what is important and not the rest of the things. That is one very important learning for me. I used to make very bad maps. I still make very bad maps. But now I know that I should only show what is required. बाकी दुनिया भर की चीज किसी को देखने में कोई इंटरेस्ट नहीं है. जो आपको दिखाना है, जो आपका स्टडी है, जो आपका फील्ड है, वही दिखाइए और उससे एक पैसा ज्यादा मत दिखाइए. कि भी किसी का टाइम नहीं है बैठ के देखने और समझने का. You should only show what is visible and immediately understandable. That is one very major thing. It applies to maps, it applies to graphs. Excel is a very bad tool. लेकिन मैं भी यूज करता हूँ, ऐसा नहीं है. Excel में आप कोई भी डेटा लो, कुछ भी मैप बनाओ, एक गंदा सा मैप, एक गंदा सा ग्राफ बना के दो. But you have to improve that. It is your responsibility to improve that graph. I'll show you one graph in this paper. These graphs were made in Excel only, but Excel doesn't make these kinds of graphs. पहले तो एक blue line खींच देगा वो, हर चीज के लिए एक blue line होता है उसके पास. Your legends, these are not, generally it will make zero crossing line. What will happen if I make zero crossing? All these points will get clumped in one corner here somewhere. But I don't want to show that. I want to show that there is a spread of values. I want to show that my points are evenly distributed in the line of best fit. So many a times these are not readable at all. Many papers I have seen. ये जो आप एक्सेस में जो नंबर्स लिख रहे हो, जो लेजेंड लिख रहे हो, आर स्क्वायर लिख रहे हो, इट इज अनरीडेबल मैक्सिमम टाइम. एक्सेल ने कुछ बनाया, वहां से उठाया और डाल दिया, ऐसा नहीं. It may be graph, it may be map. You have to look at it, show it to your friend, and ask him whether you can read the information. That maybe he does not understand that information, but at least पढ़ने में तो आना चाहिए. So that is, oh my God, I am not sharing my screen. Oh, sorry. So the map I showed you, I was showing this graph. Yeah, this graph you should see. It's a very simple graph, but it conveys the information that I want to tell the reader. That my sum of lights range, my x-axis ranges from 2400 to 3900. My y-axis ranges from 200 to 800. I don't want हर 10 पॉइंट पे एक डिवीजन नहीं चाहिए मुझे. मोटा मोटा बताने से चलेगा. What is the x-axis, what is the y-axis, all these figures should be very visible and no other additional information. Excel बीच में लाइनें भी खींचता है, ग्रिड लाइंस, उसकी क्या जरूरत है? किसी को मतलब है कि ये पॉइंट कहाँ लाई करता है, 612 या 614. It lies somewhere between 500 to 600. That is visible. That is good enough. You don't need additional information. So one very major learning which I had and which I want to tell you also is that show only information that you want to show. Don't show anything else. Mat dikhao. If your guide thinks or if the journal reviewer thinks that you should show additional information, then you add. Otherwise not. अब उसके अलावा बहुत सारा ज्ञान है और नहीं, बस इतना ही.
Sir, there are a few other questions posted in group. So if you would like to take all those questions.
A few more, a couple of them.